Very good morning to all presenter here. My name is Tuswan as the second author from Department of Naval Architecture, ITS Surabaya. Before I get started, I would like to express my appreciation to all the presenter who gives valuable knowledge to us. I would like to present our research entitled Assessment of Debonding Failure in the Sandwich Plate of the Stern Ram Door of Ferry Roro using car nearest neighbor. The application of sandwich material of the ship structure is currently limited to plate structure component. This is due to the sandwich structure is still prone to various damage because it requires a complex manufacturing process. In reality, this debonding damage can be seen by direct observation. From the background, it is important to detect the damage to ensure the safety and durability of the ship structure during operational. Understanding the fact that the ship structure is large, complex, and difficult to access in a critical location of the structure, one of the damage identification methods that can be applied to ship is the vibration-based damage identification method. This vibration response-based damage identification method uses change in structural dynamic characteristic to identify the damage. Identification of debonding on the sandwich structure using KNN algorithm is proposed. Classification using KNN algorithm needs to be measured to obtain high accuracy of the proposed algorithm. To check the validity of the proposed algorithm, so in this case, cross-validation method using various coupled and iteration is used. One type of debonding, one type of damage of the sandwich base ship structure that often occurs is debonding. Debonding is caused by the lack of adhesive layer bond between skin material and core material. Several factors influence debonding, including the large difference in thickness between skin material and also core material. The second cause is the large differences in modulus of elasticity between the skin material and also core material. In this case, debonding is located in the stern ram door of Ferry Roro 3000 GT. The amount of debonding damage is 1 to 50%, which is assumed to be percentage of the ratio of the debonding area to the total area of the interface layer. Linear snackboard KNN algorithm is method for classifying object based on the learning data that is closest to the object. KNN is supervised learning algorithm where the result of the new query instance are classified based on the majority of the categories in the KNN algorithm, where the class that appears the most will be the class resulting from the classification. So to calculate the distance between 2 points in this KNN algorithm, the Euclidean distance is used as stated in the equation. Coupled cross-validation is a type of cross-validation test that assesses the process performance of algorithm method by dividing the sample data randomly and also grouping the data as much as possible the coupled value. Coupled cross-validation is method for evaluating classifier performance, and this method is compatible with limit amount of the data. In this case, we use 4 class category explain classification of sandwich plate condition which are healthy, small damage, medium damage, and large damage, which is not from 0 to 4. There are 140 input data in numerical simulation obtained from numerical finite element analysis with 8 different dynamic response feature. These features of the data are frequency in mode 1 and mode 2, displacement amplitude in inside and outside, velocity amplitude measured in inside and outside, and also mean contact, normal, and shear force. In this case, the test was carried out with two scenarios. The first, changing the K value in the KNN algorithm into sig variation. And then the second scenario is conducted by changing the value of the K-fold in cross validation, which is varied into 5 variation. And each combination will be iterated 3 variation, 30, 60, and 90 times to overcome the bias in calculating the predicted value. So this is the comparison of the level of the accuracy for each iteration in each K-fold and each K. The accuracy value is obtained from the confusion metric, which is calculated by dividing the total number of the correct prediction in the confusion metric by divided by the total number of dataset times 100. From the figure, it can be found that the model without cross-validation the highest accuracy result were obtained using K3. Then the model with cross-validation on K-fold 3, which was carried in 3 different scenarios, different iteration, result in the highest percentage of the accuracy of 97.24% at 30 iteration and K3. The increase in the number of K in the K-fold 3 caused a decrease in the accuracy. And also in K-fold 5, the greatest accuracy is found at K3 at 90 iteration. For K-fold 7, the highest accuracy can be found at 90 iteration and using K3. With the same parameter using K-fold 11, the highest accuracy obtained can be found in K3. So, from all the accuracy data, the best accuracy is obtained at the number of K-fold 11 with K3 and iteration 90. It can be found that from the result, the addition of the number of K as soon as the can reduce the accuracy, because the more naive boards, the higher the bias can occur. This is the effect of the level of the accuracy on the various of K-fold is presented. In general, increasing the number of K-fold can increase the accuracy of the algorithm. It causes them to have the same opportunity as training data and also test data. The same phenomenon occurs that the level of accuracy increase with the increasing of K-fold in iteration 60 and also the 90. From comparative analysis, prediction were made using KNN algorithm without using K-fold cross validation or K-fold 2 but only divided the dataset into two as the test data and training data. This comparison only changed the KNN parameter but obtains the lowest accuracy result compared using coupled cross-validation. So, prediction tests with two scenarios have been carried out. That from the research, it can be found that high accuracy are obtained by increasing the number of couple. So, from the conclusion, algorithm development of debonding detection in the sandwich plate system of the shape structure is proposed using KNN algorithm with combined with coupled cross-validation. A total of 140 dataset is tested with three variation scenarios with using various of value, coupled value, and the iteration. It can be found that coupled cross-validation can increase the accuracy level. High accuracy can be obtained by increasing coupled value and decreasing coupled value. The prediction result shows the best accuracy achieved at CAL3, coupled 11, and 90 iteration with an accuracy of 97.6%. Thank you for the attention.